Okay, we're going to look at the next question here in this problem. And the next question is, show the angle D has to be 72 degrees. Show that angle D is 72 degrees. Well, there's some work we've got to do first here. We can figure out this angle DFE, and we know that it's 2x. And why do we know it's 2x? Because we've got a triangle here. We know this is a straight line. This is the exterior angle of a straight line. And the exterior angle adds up to the sum of the two opposite interior angles, which are x and x. So x plus x is 2x. So there you go. DFE is equal to 2x because of the exterior angle of a triangle. Now let's see, can we get another one that's equal to 2x? Hey, these two sides were given to be the same length. They sure don't look like the same length, but diagrams are not drawn to proportion. So that's 2x as well, because equal angles opposite equal sides. Now, all of these angles we know must add up to 180 degrees. So 2x and 2x and 1x is 5x. Dividing by 5, 180 divided by 5 is 72 degrees. So that angle right there must be D, must be 72 degrees. Let's look at the next two questions. First question is, prove the triangle DGE, this big triangle, is similar to triangle DEF. Well, if they're similar, then then it means that their angles match up. All we have to do is match up the angles of the big triangle DEF with the small triangle DEF right there with the big triangle DGE. And when we do it, angles D must be the same, and G and E must be the same, and E and F must be the same. Must work out that way. Okay, let's give it a try. Well, the first thing is that both the little triangle and the big triangle both share D. So D is common. So that's it. If we can find one more angle, let's try and find one more angle, and I think we can. DEF, that X is the same as DEF is the same as EGD. They're both equal to X. And we proved that before in question 9.1.1, and we've proven it before. Once you've matched up two angles, you can say that the triangle DGE is similar to the triangle DEF. We've matched up, we've matched up the angles. The G and E kind of match up there, right there, and that the angle D in common. So that means all their angles must match up. It means that triangle DGE is similar to triangle DEF. Now it says, prove that DE squared is equal to DF times DG. Ooh, that looks kind of strange like that, but you know what? All it is if you've got a similar triangles, then their sides are proportional. So this DE must go with this DF. So you just make a fraction. DE goes over DF. Let's see how I did that. DE goes over DF. See how I did that? I matched up those two. And the other one is DG must go with the first two here over DE. I just make the ratios. But why can I do this? I've kind of left something out. The reason I can do this, the reason I can say that DE over DF equals DG over DE is because they are similar triangles. So I actually I should write that in there. I should, because they are similar triangles. That's why that's the reason that I can say their sides are proportional. So you're going to have to write that in there somehow. I mean, you give a reason in geometry. Okay, and I left it out. That's bad. And now I don't have to give the reason here. It's just algebra. I cross multiply. I get DE squared equals DF times DG. So you go straight to here. So if the triangles are similar, their sides are proportional because they are similar triangles. And that's why DE squared equals DF times DG. And there we go.